Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published just last week, which introduces a new method that boosts an AI agent's performance by an average of 14% on several key benchmarks. The paper is titled TaskCraft, Automated Generation of Agentic Tasks. So the big challenge this paper tackles is creating good training data for what are called agentic tasks. These are complex, multi-step problems that require an AI to act autonomously, using different tools and reasoning on its own. Building these tasks usually takes a lot of manual human effort, which is slow and expensive. TaskCraft automates this entire process, generating around 36,000 verifiable tasks of varying difficulty. It does this by cleverly extending simple problems into more complex ones, and as we'll see, the data it creates significantly improves agent performance. Also, the authors shared their work on GitHub. You'll find a library for generating these difficulty-scalable and multi-tool agentic tasks we discussed. The code and data are currently under a review process, but they expect to release everything in the next few days, so be sure to check back. Alright, so this first figure shows us the very beginning of the TaskCraft workflow, how it creates what the authors call an atomic task. Think of an atomic task as a simple, single-step problem that acts as a building block for more complex ones. The process starts by taking an unlabeled document, like the PDF report shown here. The system uses a tool to extract the text, finds a specific answer, in this case, $383.3 billion, and then works backward to create a question that requires that specific information, ensuring the task genuinely needs the tool. Okay, building on that idea of atomic tasks, this next figure shows how TaskCraft makes problems more complex using a method called depth-based extension. Essentially, it chains simple tasks together. So on the left, we have our atomic task. Interstellar's director. The system then takes the subject, Interstellar, and creates a new, related question that leads back to it, like, what science fiction film was released on November 7th, 2014? Finally, it merges these into one multi-hop question. A hop is just one step in a multi-step problem. This creates a verifiable two-step problem for the AI. So, the other way TaskCraft increases complexity is through what the authors call width-based extension. Instead of chaining tasks one after another, this method merges them side by side. Here we see two simple, distinct questions, one about Apple's earnings per share, or EPS, and another about its P/E ratio for the same period. An LLM then intelligently combines them into a single, more complex question. This forces the agent to resolve multiple subproblems to find both pieces of information, creating a broader, more challenging task from simple parts. Okay, so, after creating tasks with both depth and width, the authors needed to see if their automatically generated problems were actually as challenging as human-made ones. This table shows that comparison. It tests an agent on the GAIA dataset, which is a standard, human-curated benchmark with 3 difficulty levels, against the synthetic tasks from TaskCraft. The results are really interesting. The agent's average accuracy is very similar across both sets, and notice the synthetic image tasks, with an accuracy of just 22%, are nearly as tough as Gaia's hardest level. This shows the automated method can produce genuinely difficult tasks. So the natural next question is, if the tasks are hard, can they actually make an AI agent smarter? This table shows us exactly that. The researchers tested a couple of models on standard multi-hop question answering benchmarks. They then trained them using a process called supervised fine-tuning, or SFT, which is where you show the model many examples of a task and the correct steps to solve it. The results are dramatic. Across the board, adding this supervised fine-tuning step with the new data leads to huge performance jumps, proving these synthetic tasks are incredibly effective for training. Alright, to wrap things up, the key takeaway from the TaskCraft work is really twofold. First, it offers a scalable, automated way to generate what are called agentic tasks. These are complex problems that require an AI to reason through multiple steps and use tools, breaking the bottleneck of needing humans to create them. Second, and perhaps more importantly, these synthetic tasks are highly effective. They not only match the difficulty of human-made benchmarks, but also dramatically improve agent performance when used for training. That's all for this week's AI Research Roundup. Thanks for tuning in.